Okay, here we have a quick little video that's going to be over some college algebra problems. I've got an assortment of problems that are probably the first kinds of problems that you might encounter if you take a college algebra class. That's not true for every class at every school everywhere, but for the classes I teach, this is what you'll encounter in the beginning. Okay, so let's take example 1. Solve the equation 10 minus 3x is equal to x. And I might say, since we're starting at the very beginning, what does it mean to solve an equation? I guess that notion is not that complicated. Take this one. This one's a little bit simpler. All right, they're both equations, obviously. But whatever would solve this equation or whatever would solve that one is the value that the x takes that makes the equation true. All right? And even if you didn't know how to solve this one, you might be able to think of that number. All right? Now I'll make a proposal to you and I'll see if you think it's correct. 5. Would 5 do it? Let's see, what's, say you plug 5 in for the x. What's 2 times 5? It's 10. And what's 10 plus 1? It's 11. And that would certainly work, and that's what makes it a solution. So we're always just, at least when we begin learning algebra, we're looking for solutions to equations. Why do we do it? Well, that's a big story, and it depends on what field you make your profession. But that's what we do in college algebra. Now, when we solve this one, I guess the point of solving any equation is to transform it to the point where the answer is really obvious. Okay? So, you do things like move the numbers around, and if you have a square root symbol that's in the way, then you find a way to get rid of it. So, for this one, here's what we would do. Okay, I can, in general, when I'm solving an equation, I can do the same thing to both sides. Okay, so say I decide to square both sides. That would cancel the square root. And that's probably easy to believe that would happen. But whatever I do to one side, I do to the other. So I square the other side too. You might think of it that an equation is a balanced scale. That's an equal sign. It says that this thing is the same thing as that, even though they look different. And if you want to keep them equal, then you need to do the same thing to each one. All right. So what would happen if we square both sides? Well, the squaring would cancel the square root. We would just get 10 minus 3x. Okay. And then what's x squared? X squared is just x squared. All right. Okay, now we get here, and that looks, or at least it should look a little bit better than what we started with. All right. Now the next issue is, we're here, how do we take it further? When I notice that we have an x squared term, that tells me that it's probably going to be a quadratic equation and that we could probably solve it by factoring. And the whole idea with factoring is we get 0 on one side, we move all the other stuff to the other side, and we try to factor it. So what happens if you move a term from one side of the equation to the other? It just changes sign. You might think of it like, I'm going to subtract 10 from both sides, just like I would square both sides. Remember, what I do to one side, I got to do to the other. So I'll subtract a 10, and that'll make, what's 10 minus 10? It's nothing, it's gone, and I get negative 10 over there. And I would add 3x. What's negative 3x plus 3x? It's nothing, it's gone. Leaves me 0, nothing. I get a plus 3x on the other side. So I'm going to get an x squared, a plus 3x, and a minus 10. All right? Okay. Now for this deal, here's what we're thinking. We're thinking, all right, this is not the only way to do it, but it's hard to do problems, and show, 10 ways you can do everything. So I'm going to just say like, well, that I could factor. That's the kind of thing I can factor. And what's factoring? Factoring is the reverse of multiplying. So let's put another note over here. Say you're back in elementary school and you learn to multiply and then you learn to factor and you say, can you factor 10? And what's that asking? It says, what do you multiply to get 10? And you think about it because you learn your times tables and you say 2 times 5 is 10. So we got to do something like that, but with this, now the trick to doing these is, let's see if you agree with my beginning. The kind of thing that would multiply to get that would be 2 binomials, each with an x. Because what's x times x? It's x squared. Okay, now from there, to decide on what these numbers are, here's the trick. I have to think of 2 numbers that multiply to -10 and simultaneously add to 3. Positive 3. So can you just, pause right now if you want to. Can you think of 2 numbers that multiply to -10 but simultaneously add to positive 3? That would be a +5 and a -2. Well, let's try it out. What's 5 times -2? It's -10. What's 5 minus 2 is +3. Now, if you want to, you can multiply this whole thing out. Use FOIL multiplication. You'll get that next thing. You'll get it. You'll prove that you're right. All right, but that's how you do it. If factor in something we got to review, then you have to let me know, and I can tell you. I can tell you more. Now, why do we get to 0? Well, isn't it true that if one thing times another thing is 0, doesn't one of these things have to be 0? I mean, how do you multiply to get 0? And this is multiplication. Yeah, one of those things got to be 0. So we take advantage of the fact that it's this times that. It's equal to 0. So we say, well, 0's got to be x plus 5. Or the other possibility, 0's got to be x minus 2. One of those things got to be 0. And what would it mean the x is if x plus 5 was 0? That means that x was -5. And what would it mean if x take away 2 is 0? That means that x was 2. Right? All right. Well, check it. What's -5 plus 5? Nothing. It works. What's 2 minus 2? Nothing. Okay, they both work. They both work. Now, here's a little bit of a catch. There's a reason for this. I could tell you the reason. I'm not sure if I told you if it would help you, so I'm not sure if I told you the reason if it would help you, so I'm just going to tell you something. Anytime we square both sides, there's a kind of flaw to that, and it's that we must check the answers. Okay? Like, doing that, this step right here, it works, but it can it'll give you all the right answers, but it might make some that don't actually work show up. Okay? So, I guess you can check any problem, but here I'm saying you have to check it. All right, it's not an option. One of those could be a false answer. So, how are we going to check it? Well, how did we know that 5 was an answer to that one? We put it in, we see if it works. So, take that very original equation and put both of these in, and we'll see what happens. So, I'm going to check -5. And here's what that's going to look like. It'll be, now I'm putting it in the original equation, the way it was written on the paper right when we were going to solve it. It'll say 10 minus 3 times -5 equals to -5. And I put a question mark as if, could that be right, or is that right? So what's this say? That says, what's a negative times a negative? It's positive 15 and 10. That's 25, all right. And is the square root of 25 -5? No, square roots, the square of a number is not negative. That's just the way it works. If you don't believe me, you can say, all right, what's the square root of 25? What is that? Does that say? No, it doesn't say -5. All right. So let's put an X there. You know, I was wondering if it was right. It's not right. It did not work. That's not a solution. Let's try this other one then, 2. You know, maybe 2 works, maybe it doesn't. We'll check and see. Remember, you must check. So 2, what's 2 look like if we put it in that original equation? I get 10 minus 3 times 2 equals to 2. All right? That original equation, before I did anything to solve it, I'm putting this supposed possible answer, and that's what we see. What's that going to say? 10 minus 6. What's 10 minus 6? It's 4. Is the square root of 4 2? Yeah. 2 squared is 4. The square root of 4 is 2. So here I'm going to say, I agree with that. That's correct. I mean, it seems a little silly, but if you want to, you can check on your calculator and say, what's the square root of 4? Yeah, it's 2. So it works out. All right, so here's what we'll do. We might want our work to be seen, but we'll say like, okay, right there, that's my final answer. Okay, I don't box that one. I don't indicate that's my answer because it didn't work, and that's the reason for it. Okay, now that's one kind of an equation that you might encounter. Now about, say something like this. Okay, here's something that looks very different. It says x to the 5 over 2 power. The power is a fraction. Okay, x to the 5 over 2 power is 32. Now, just like we had, you see the square root, we had a way of dealing with that. And we said, well, you square both sides. That's how you deal with it. And here, it's like, in order to get this down to where I have like an obvious answer, I have to do something with the 5 over 2. I have to address the 5 over 2, okay? So here's what we do. First, I'll tell you what we do in this case, and then I'll tell you the reason for it. I will raise both sides of this equation to the 2/5 power. Okay? All right, now why is that? Well, what happens, let's put a note here. We do a little bit of reviewing. What happens when you just, like say hypothetically, you take something that's raised to a power and then you raise it to an additional power? What do those become? I mean, how many x's are you going to have there? How many x's are in the parentheses? 2, because it's x squared. And how many of those do you have? You got 3, so you're going to get 6. Whenever you raise a power to a power, you multiply the powers. Okay? Now, if you ever forget that, and there's lots of stuff in math, and it's, lots of rules, it can be easy to forget, then let's break it down like this. X squared is x times x. That's what the power 2 means, right? It says repeated multiplication, x times x. Well, say you got 3 of those, that to the 3rd power. So x times x, there's 1. X times x, there's 2. X times x, there's 3. How many x's do you see? 1, 2, 3, 4, 5, 6. Yeah, so I'm just saying, like, here's how it's always going to work. You raise a power to a power, you multiply them together. Now, so why then would I take the reciprocal? Why would I turn that upside down and say, I'll apply that to both sides? Remember, what I do to one side, I got to do the other. Well, okay, so aren't we raising something to a power to another power? Yes. And what do you do when you do that? Well, you multiply them together. And then, well, what's 5 over 2 times 2 over 5? It's 1, okay? And so you're just going to be left with an x. That's it. All right? Now let's make another little review if we have to. Do you know 5 over 2 times 2/5? Do you know how to do that? Just in case you don't. So 5 over 2 times 2 over 5. The way we multiply fractions is we multiply them straight across. That's just how you do it. I mean, in math, there's a way you do everything. to multiply fractions is to multiply straight across. No need for a common denominator or anything. And so there's different ways you can think about this, but how about we'll just do it like that. What? Straight across. 5 times 2. That's 10. Okay, over. On the bottom, 2 times 5. What's that? 10. What's 10 over 10? 1. Okay, so what's the power over here? You multiply those together. It's just x. So we're going to get x, and we'll get 32 to the 2/5 power. Okay. Now, at this point, I guess, it looks like you got your answer. You got 32 to the 2/5 power. Here's one way you can do it. I'm going to insist on showing you two things right here. But we could do like this. Here's my calculator. 32, and I want to take that to the power that's 2 over 5. See? I type it in just like that. 32 power, and the entire power is the number 2 over 5, which you notice I put in parentheses. And it will give me an answer. It will tell me 4. All right? So it appears that I get my answer. Okay. Now, I still think you should know how to do that without your calculator, because just because somebody has a calculator doesn't mean they know how to get it to work the right way. So I'll show you a different way, okay? So let's say I had some notes and I'm doing a little reviewing, but so here's my third note, okay? What does 32 to the 2/5 power mean? Like, what does it mean if you have a fraction power? All right. Well, each of these numbers is applied individually to the 32. The 2 will be the power, and the 5 will be the root. And you apply them one at a time to that in whatever order you want. So we could do like this. We could say, all right, here's what this means. The 5th root of 32. Okay, so I'm going to do the 5th root first. And then to whatever that is, I'll say I'll take that to the 2nd power. Okay. All right, 5th root of 32 says, what do you multiply by itself 5 times to get 32? And that happens to be 2. Try it for yourself. What's 2 times 2 times 2 times 2 times 2? It's 32. And then I need to take that answer and square it, and I get 4. And what did the calculator tell us? 4. All right, so now you can't get your calculator to work, or you don't know how. At least you know how to interpret that fractional power. All right. Okay. So there we have it. Now, you don't, in this kind of problem up here, the checking it is a must. You square both sides. That's the way it is. You have to check it. Here, I guess, if you do it right, you don't have to check it. But it doesn't hurt. Why not? Let's try it. So the answer's supposed to be 4. So I'm going to take 4. I'm going to raise it to the power. I'm going to put this in that original equation. 4 power 5 over 2. And I get 30. It must be right. I get 32. Okay. All right. Now, we'll take one more that's like a tiny step beyond what I was just showing you. Here we got, instead of just x 5 over 2 powers 32, we got x minus 3. Okay. And when we solve equations, there's a certain order that we do things. Like you might know that you have to address the 5 over 2 being there, and you have to address the 3. But it wouldn't be, we'd be getting things out of order if we said, okay, add 3 to both sides. Now, the 3's stuck in there. We got to deal with that 5 over 2 first. All right? How do we deal with that? What do we do with an exponent that's a fraction? Well, we just saw that over here. That's why I told you about that one first. So, all right, we'll say, here's our problem, and we'll take both sides to the 2/5 power. Okay. And then these, as we talked about, you multiply the powers together. When you take something and raise it to a power and then another power, you multiply them. and that's going to be 1 in this case, and you're just going to get x minus 3. And then we already figured out what that is in the last problem we did. That's going to be 4, okay? And I wrote that parentheses, but do I really need that? No. I mean, there's, it was there in the beginning, but why? Well, to say that the power applied to the whole thing. It's like x minus 3, that whole thing got the power, but all right, it's gone now. It's just a 1, and we're here. So now what? Well, we're here, and I want to know what the x is, and if I could only get the x all by itself, I would have my answer. So if that's a minus 3, what can we do to move that to the other side? Well, as we saw before, we can add 3 to both sides, right? And we get x is equal to 7. Okay, and then 7 will be our answer. And you can put 7 in there, and you can check it and see for yourself that it works. Okay, so we solved some equations. Now we'll go on to a different topic that's a little bit more, I guess you could say the math's not that hard, but you have to understand the concept, okay? So you'll come across in algebra class the idea of y being a function of x, okay? And that's the way the terminology is going to be used. And so that's got to mean something, and you're going to take the class, you got to know what it means. And here's what it means. It says it means that x and y are paired together in a way that each x is paired with exactly one y. Okay, now let's talk about that a little bit. What do we mean if we pair them together? Well, here's an example. So say that x is the time of the day and y is where you are. Okay, and you could pair those things together. I mean, isn't it true that at every moment of the day you've got to be somewhere, right? So like, okay, how about this? When we write this kind of stuff down, if we're going to pair things together, then we might put them in pairs, like see the parentheses with the comma. That means I'm pairing these two things together. And I might say that, okay, the time of day paired with the location, x is the first spot, y is the second. At 7 a.m., maybe you're at home. At 9 a.m. you're at school, and at 5 p.m. you're at work. I mean, so they're paired together, all right? Now, is it true that every x is paired with exactly one y? Like, does 7 a.m. get paired with 2 different y's? Like, 7 a.m. gets paired with home. 7 a.m. gets paired with school, too. No, it's like, here, every x gets paired with exactly one y. So I would say, like, if I'm given something like that it's a function. Okay? Now, somebody could say, well, all right, who cares about that? And why does it have to be this way? And, what difference does it make if each x is paired with exactly one y? And it's kind of like this. It's like every time that we do something on our calculator and we press enter, then there's one answer. Like whenever we do the math and you do all the adding and subtracting and whatever you're going to do, when you press enter, you get one answer. Okay? It's kind of like saying that when we do stuff, we like one output, one answer. But another way you can think about why it has to be like this is because, say I paired something like this up. All right? Okay, so here's a pairing up there where I take x to be the time of day and y to be the location, and I say, okay, at 7 a.m. you're at home, 9 a.m. you're at school, and then 9 a.m. you're at the doctor's office. I mean, does that even make sense? I mean, that's impossible. It's not a function, all right? At 9 a.m. you can't be at school in the doctor's office. At least I don't see how you could be. So you might look at it like this. You might say, it's not a function because at 9 a.m., that being the x, I get paired with school and the doctor office. Okay? And that just can't happen. All right? So I guess you could say that the reason that we name a function like this is because it does correspond to the way that many normal things would work. You know, like how you would pair the time of day and your location. It could never be that one x gets paired with two y's. All right. All right. So this one is not a function. All right. So that's the concept. Now, once you get the concept, I guess it's not hard to answer the question. So, you know, in a math book, you might see a question like this. It gives you a list of ordered pairs, and all that is that, you know, this number represents an x, and this other number represents a y, okay? And it's x and y and x and y and so on and so forth. So, anyway, you know, is it like that up there? Okay? I mean, is it as simple as this? Are the x's and y's paired together in such a way that every x is paired with exactly one y? Well, look at the x's. I guess if you see the x's repeat, that means that one x gets paired with two y's. You know, I look at this and I say 3, that's an x, and it gets paired with a 5 and also a 7. Okay? It's not true that one x or every x gets paired with exactly one y. So is y a function of x? No. The answer to that question, no. Okay. All right. So there's our short video. Get people started in algebra. There's with anything more that I can say. But this will get you started. If you have questions, just ask them. Thank you.